Hi, I'm Guy Powell, and welcome to the next episode of The Backstory on the Shroud of Turin. If you haven't already done so, please visit guypowell.com and sign up for more episodes. I am the author of the upcoming book, The Only Witness, a historical fiction tracing a possible history of the Shroud of Turin over the last 2 millennia. Today, we'll be speaking with Tom McAvoy. He's one of the preeminent researchers on the Shroud of Turin. We'll be talking about some of his research on dating the Shroud. So with that, let me tell you a little bit about Tom. Tom received his Bachelor of Science in Chemical Engineering from Brooklyn Polytechnic Institute in 1961. He received a PhD in Chemical Engineering from Princeton University in 1964. He taught chemical engineering for 40 years, initially at the University of Massachusetts, and then later at the University of Maryland. Tom is currently Professor Emeritus at the University of Maryland, where he holds joint appointments in the Department of Chemical and Biomolecular Engineering, the Institute for Systems Research, and the Bioengineering Department. He's written and presented a number of papers on the Shroud. In 2019, he published one paper in Applied Optics and one conference paper on his research on the analysis of the UV photos taken of the Shroud by STIRP photographer Vern Miller in 1978. In 2019, he also gave 2 presentations on his UV research to the Shroud Conference held in Ancaster, Canada. In 2021, he published a second paper in Applied Optics on his analysis of the UV Shroud photos. And here he also published in the International Journal of Archaeology entitled On Radiocarbon Dating of the Shroud of Turin, and that can be found at researchgate.net, researchgate.net. And Tom continues to conduct research on topics related to the Shroud today. So Tom, welcome and thank you for being here.
Well, thank you very much for that very nice introduction.
Oh, you're quite welcome. It's a pretty amazing. And I will admit, I grew up outside of Princeton, so we were in Princeton right about the same time. So phenomenal.
That's great.
So you're right up there with Albert Einstein and some of the other professors there.
That's pretty rich company.
Yeah, that sure is. But good for you. So anyway, so tell us, how did you get involved with the Shroud? Tell us your backstory on the Shroud of Turin.
I had a neighbor that recommended a book back around 2012. I don't remember the exact year. And it had a chapter in it on the Shroud of Turin. And my initial reaction was, gee, I think that was shown to be a fake. You know, when they did the radiocarbon dating in 1988, I knew very little about it at that point, other than, you know, remembering that. And so I got interested in it and started looking a little more at it. In 2014, I attended the Shroud Conference in St. Louis and listened to all the papers there. And that kind of increased my interest in the Shroud. And about 1.5 years or 2 years later, I got a copy of Mark Antonacci's book on Test the Shroud at the atomic and molecular levels. And I was fascinated with that. So I started emailing Mark, and I actually had some telephone conversations with him. He was very, very good about sharing his time and energy and whatnot. And so we were interacting on a relatively regular basis around, say, 2018. And there was a meeting held at Bob Rucker's house in 2018 that I attended. So that's kind of the background. I hadn't published anything as of 2018, but I had developed an interest in the Shroud. So that's kind of the story of how I got interested in it.
Yeah, fantastic. And certainly with Mark Antonacci, and then your recent papers here also talk about some of the research that Robert Rucker has done on the neutron theories and related to that. And so you said you got interested then as well in the UV photos that were taken by STIRP in 1978.
Exactly. My interest in that was came about from just getting, doing more looking at papers. And there was one that was actually given at the 214 conference by Ray Schneider. It wasn't until 2018 that I really dug into it. I had kind of an inspiration, I remembered something and went back to look at it. And he based that paper, part of it that I was interested in, on some work that John Morgan had done in 2012. He was at Towson University, and he applied a technique called principal component analysis. It's a statistical technique that I had used, many, many times in my research. And Morgan applied that to an ultraviolet photo of the shroud. And he presented his results. The photo that Morgan looked at included the radiocarbon test areas that the three labs had done. And what he gave were average values of a statistical parameter that he calculated for each of these three areas. One of the labs did 5 tests, another did 3, another did 4, but they reported 4, they actually did 8. So you have the average values of this statistical parameter that Morgan published. And then Schneider took and I'll get a copy of this and I'll show it to everybody. He took Morgan's data and he made what was an amazing plot to me. I'm going to hold it up and hopefully people can see the plot. I hope that's hot enough.
Yep.
And the y-axis of the plot is essentially it's years before the present. So that's essentially the radiocarbon date. And you see 3 diamonds in the plot. This is taken from Morgan's paper. It's figure 5 in his paper. And the paper is available on shroud.com for those that want to look it up. So the 3 diamonds are the 3 average values for the 3 labs. And the x-axis is something called the z-score. That's the statistical parameter from principal components. In my later research, I showed that the z-score is essentially related to the fluorescence intensity that you would, in this case, if you're averaging it over a region, it would be the average fluorescence intensity of each pixel in the region that you're averaging over. Now, if you look at the plot, I hope people can see it, you get almost a straight line. And the most amazing thing to me is the R squared value. R is the correlation coefficient. And the R squared value is something called the coefficient of determination, and it's 0.9986. And in all my work, I've never seen anything that high. It's like, wow. And his caption says, nearly perfect correlation between average carbon dates and the UV fluorescence measured by PCA. So I said, wow, I've got to look into that a little bit more. And that piqued my interest in the ultraviolet photos. I said, what that could indicate is that if these things really, if that correlation was really true, if you can get an ultraviolet photo of the shroud or several and analyze them, you can come up with a prediction of the radiocarbon date.
Right.
So that's what piqued my interest. And it was around late 2018 that I looked at Schneider's paper.
Well, it's interesting when you get a correlation that high, and my other business is in marketing and analytics, and so we do a lot of statistics and machine learning nowadays and AI. Right. And if you got a correlation that high, it would be suspect. And and so you've got to, just like you're doing, you've got to investigate further. How could there be a correlation which is so close to 1?
Exactly.
And so yeah, so go on.
Well, that led me then to start looking at where can I find UV photo images of the shroud. It turns out that the site that Morgan had used, Morgan downloaded the image that had the radiocarbon area, and that site no longer existed, so you couldn't download anything from it. And I tried to contact him because he lives or he works close to where I live in Maryland, but I never made contact with him. I did continue to work on a copy of that photo he used, and then lo and behold, in the spring of 2019, Gil Lavoie, who's an MD, and Tom DeMulla, who was part of STIRP, published 44 transparencies on the web that were made from ultraviolet photos that were taken by Stirp by Vern Miller in 1978. So that's almost, I guess, close to 40 years or maybe even more. And these were transparencies. They were not photos, and they were made from the original photos or the negatives that Miller had. Now, let me say a little bit about ultraviolet fluorescence and why, how it works. When you take an ultraviolet photo, you want to make sure that your source is pure ultraviolet, that there's no visible light in it. So you put a filter on it and you have ultraviolet that is aimed at the target that you're photographing. And then you do not want to pick up any reflected ultraviolet light in your camera. What you want to pick up is the visible light that the ultraviolet creates in the target. So the ultraviolet goes in, it actually interacts with the molecular structure and the composition of, in this case, the shroud, and pops out in visible light. And so you put a filter on your camera to filter out any ultraviolet reflected light. And now what you have is interesting information, because the ultraviolet image reflects the molecular structure, but there's not a one-for-one correspondence. You can't take it and say, oh, I know that this is silicon or this is that. It's just, if you get two different values, then you can say that the molecular structure or the composition of what you're photographing is different in those 2 points. So it's not an exact relationship, but what you get from it is data on the shroud itself, that the UV images have captured data on the shroud and how its molecular structure and its composition react to the ultraviolet light that's being shined on it. So what I found was that there were a number of issues with those transparencies. One was they had an orange color, if you look at them on the web. And that puzzled a lot of people. And I think the last paper I published in Applied Optics showed that the orange color was due to some filtering that Miller must have been experimenting with to try to probably emphasize the blood marks. But he was filtering out, I think it was green and yellow, I forget, it's in the paper which filters he was using. It's written on the side of his transparencies, the filter type. So that was one question. The other problem was that the lighting that he used was not uniform. So he had a light such that the center of the image got more ultraviolet light than the edges. And that creates a problem if you're trying to compare different pixels, because if a pixel doesn't get as much ultraviolet as another, then how do you compare the intensity that's being generated there? So the three papers that I wrote, one in the Ancaster Proceedings, which is on shroud.com, and the two in Applied Optics go over all of that. I don't want to go into that, but I want to talk about the results. And so here's a second slide, if you will. It shows the shroud, and there are 3 lines on it. It also shows the radiocarbon area down on the lower right. The 3 lines are red, green, and blue. And what Miller did was they had the camera on something like a track, and they would move it down the shroud, and it would take about 8 photos going from left to right to cover the whole shroud. So the red area, or the red line, shows the center of the focus for the camera. It's focused on the center of 1/8 of the shroud, but that's the line down which the track moves. And he takes 8 pictures, and he gets then eight parts of the shroud, and that would be basically from the top to the green line. Then the blue line shows the same thing, except he's getting the bottom part of the shroud now. So he's coming up from the bottom to the green line. And then the green line would be taking images from between the red and the blue and moving down. So there would be 888 images that are being taken. And I've also pointed out that on the left is the dorsal side of the shroud. So this would be the part that the back was exposed to. And on the right is the frontal side. And then I've shown where the center of the torso roughly is on both of those. And this is the only slide that's not given in a paper, but it's described in that International Journal of Archaeology paper. The rest of them, I'll tell you where you can find the various slides. So that is what Stirp did.
So sorry, let me just
yeah, go ahead.
Interrupt you there. So on the red, are you filtering out for red, green, and
no. That's
okay.
Just to show the different trajectories that the camera took. So they put it on this movable track. They'd focus it on roughly 1/8 of the shroud, take a picture, move it, snap it, move it. So the pictures come together and you can get the entire shroud, but it would be half the shroud in case of red, the bottom half with blue, and then the middle half, which is overlapping with the green.
And what you're saying too is that there's an ultraviolet light that's shining on the shroud, and then you have a UV filter on the camera, so you're capturing only the visible light
that's coming
in the
out.
camera.
Exactly. And that's what the ultraviolet photos are. Now, since I mentioned that the ultraviolet light, what comes off in the visible region reflects the molecular structure and the composition of the item that's being photographed, you would kind of expect that the shroud would not have much variation in its fluorescence intensity. The fluorescence is what the visible light is referred to. The ultraviolet goes in, comes out as visible light, and that's referred to as fluorescence. The wavelength is higher on the visible light compared to the ultraviolet light. So I would have expected, relatively uniform, maybe small variations in the ultraviolet properties. But here's the results that I got. And again, let me hold this up and try to describe it. This is a plot of, and this is in the International Journal of Archaeology paper, and it's a plot of the ultraviolet fluorescence intensity versus position along the shroud. Now, because of the fact that the lighting was not uniform, you can't analyze, pixel by pixel. So I had to take averages for like the 8 photos that go down the red side. You'll get an average value for the fluorescence intensity, and the same with the blue side. And then there were a couple of missing points because there were malfunctions in taking the image. So for example, the red is missing one right about here.
Could you, could you hold that back just a couple of inches?
Sure, sorry.
Yeah, there we go, perfect.
All right. The red has only 7 points because the flash failed in one of the images. The blue has all 8. And then the green is missing, it may be missing 2. I'm not certain, I believe it is 2. Now, I would have expected values like the blue curve, that in other words, roughly constant values of the fluorescence intensity as a function of position down the shroud. But there's about a 20% or so change between the minimum and maximum value here. And if you look carefully at this, you find some very interesting properties. One is that the top of the shroud, the red values, are always higher than the bottom of the shroud, the blue values. The second thing is that the highest value for the fluorescence intensity, that's a tongue twister, is in the center, and it's actually where the torso is located, and it's on the dorsal side of the shroud. Now, the third thing, and it's a little bit more difficult in a talk like this to explain it, but I'll try. If you look at the first blue point, which is down around 2 or 3 on the graph, and you compare it to the last blue point, which is down around 22, the first one is higher than the last one. Now, both of those points would be associated with the feet on the shroud because the shroud wrapped around the body. So there's a foot image on the dorsal and there's a foot image on the frontal. Well, if you go and you compare points from the dorsal to the frontal part of the shroud, you find out that in every case, the dorsal image shows a higher fluorescence intensity than the frontal image. And that's a strange property, okay? I would have expected, as I say, something more like a constant. So what I found was that there were some very interesting fluorescence properties, intensity properties, that the shroud was exhibiting. And this is kind of where my analysis of the UV images ended in the applied optics papers, just saying, okay, here's how you analyze them, here's the methodology, here are the results I found. Can somebody explain these strange properties of the shroud? It's something that was unexpected to me to see these various differences. So that's kind of a summary of what I did on the ultraviolet photos.
Yeah, it's interesting. What I also see is that the bottom of the shroud is relatively constant, although declining. Right. Whereas the middle of the shroud, which is green, has then the highest, which would be kind of the center of the body. Yep. And then you have then the other side of the body where the red is, that well, two things. First of all, the red and the blue don't match. Right. And actually, it's also kind of interesting if you were to even plot that going top to bottom on the shroud as opposed to left to right. Right. Then you would also, there's also a difference in there, which is kind of astounding, because to your point, you would have, I would have expected to be either equal or potentially maybe following the mass of the body or something like that, to either be the producer of the ultraviolet or the blocker of the ultraviolet, and you don't really see that at all. Yeah, these were very strange results to me and very interesting results. And, a potential problem with this is that there are things like burn holes on the shroud, and the blood does not fluoresce and whatnot. One of my conclusions is that I think it would be wonderful if UV photos could be taken of the shroud with a uniform lighting source. And so you would get pixel by pixel values down the shroud. That would be immensely beneficial. But anyway, that's kind of where my research ended, with that question mark. And I then started to say, well, okay, how can I explain this? And one of the things that I looked into was one potential explanation of this that came from Bob Rucker's work. And in 1989, when the shroud, in fact, in the same issue of, I believe it was Nature, where the radiocarbon results were published, Phillips published a little tiny, it may have been a letter to the editor, saying that if the body that the shroud wrapped emitted neutrons, that could have affected the radiocarbon dating, because what would happen is the neutrons would create additional radiocarbon from the nitrogen in the shroud, and that would make the shroud look younger than it really was. So Bob Rucker, who's a nuclear engineer and has used nuclear simulation codes, I guess, his whole career, decided to simulate this idea that Phillips had. And in the 2014 Shroud Conference, he presented his results on the neutron simulation. And I've described some of his work in that International Journal paper of archaeology, but he's also got a great website with all of his results on it. Research, I think it's, if you Google Shroud Research Rucker, you'll come up with his site, and he's got over 30 papers on there, one of which is number 13, is the one that I'm going to talk about some of the results on. So Rucker assumed that the body wrapped in the shroud emitted neutrons, essentially Phillips' idea, but the neutrons don't cause the image. The neutrons will go through
pretty much the shroud, but they will collide with some atoms in there and cause them to maybe change chemical bonds or some other things, but they're not in all likelihood causing the image. That some other type of radiation, whether it's corona discharge or protons or something else, is causing the image. And this is a hot area for people studying. I did not get into the image. I had enough trouble with just the neutrons. So I'll show you what Rucker did. And this is again taken from that paper that I wrote. And hopefully you can see that.
Yes.
And I've got another copy over here that I can look at so that I can put it up over my face.
Yep, that's perfect.
He did something like something called Monte Carlo in-particle neutron radiation simulation, MCMP. And the figure 4 on the left is taken from his paper 13. And I'm just showing the results down the center line of the body. And he made a model of the tomb. And he assumed that the top was against the wall, whereas the bottom was open. So the top would be the red area in my UV work, and the bottom would be the blue area, and the green is the center line. And he ran his neutron simulation, and he calculated what the radiocarbon date would be. He did match the radiocarbon dating results that were calculated in 1988 when that work was done. And the curve on the right, the green curve, shows his results. So what you see plotted there are the radiocarbon dates on the y-axis and the position along the shroud on the x-axis. And I put a dashed red line there. And what that shows is the present time. So what Rucker is saying is that if there was if there was neutron radiation that occurred, that essentially, just about all of the shroud would date to the future if you were to take samples of other parts of the shroud. And
so just to clarify, so the chart on the right is if you're above the dotted line, then that would be in the future. And if you're below the dotted line, then that's in the past.
Right. And there's only a very little bit below. And that happened to be, it's in the center, but it's in the region where the radiocarbon dating was done. It's in the center, and the radiocarbon dating was done on the bottom, what I'll call blue side. You can see that there's quite a slope there heading up.
Right.
So that was interesting. And I said, So I want to show you a comparison between what I have found for the center line. Whoops, get over there. And what Rucker had. And
wow,
you can see the y-axes are different. In my case, it's the average fluorescence intensity of one of the UV images that were taken by Stirp. And in his case, it's the radiocarbon date. But the x-axis is the same. And if you look and you compare, I was amazed to see the comparison between these two, that they have the same shape, they have the double maximum. And you can see here, the region between the first point and roughly around point 11, the first 4 points in Rucker's plot, that would be the dorsal side, and the next 4 points would be the frontal side of the shroud. So you're seeing here that the dorsal is fluorescing more than the frontal in both cases.
Yeah, and why do you, any thoughts on why that would be the case, why one side would be more?
Well, if what Rucker was saying with his simulation is that when the body is lying on the slab in the tomb, if it's emitting neutrons, they would go down and hit the slab that the body is lying on and then be reflected back up. Whereas if in the front, the neutrons would just go up and they wouldn't be reflected back off of the slab. So if they go down, go through the shroud, hit the slab, come back up, then you're getting twice as much exposure as you are with the other one. So that's his explanation. In my case, it's simply data from the shroud. This is the way the shroud is fluorescing. And it's like, wow, you know. So the question then that comes up is the following, that I found that the agreement was remarkable to me. Now, Rucker also simulated what I'll call the red line and the blue line that I had. He has a lot of points down the shroud, and the trends that he published or has on his website are identical to what I found with the ultraviolet analysis I did. The top of the shroud is more affected in its radiocarbon dating than the bottom of the shroud. And the reason is that there's a wall there like this. And so neutrons would hit the wall and then come back, I guess, and bang into the shroud, and it would affect it more in his simulation. Whereas the bottom side is just heading out into the tomb.
So just to, so his is a simulation.
Right.
So what he did is he, and I vaguely remember he took more or less the mass of the body, and then what would or could have happened if there were neutrons radiated from that body. And then to your point, they either went down or they went to the side. If they went down, they bounced back up. If they went to the one side, they bounced back as well. And then if they were up, they just went all the way up.
Yeah.
And then out to the front, then they just kept going.
Yeah, there was a difference. And then I think they may have even bounced around the tomb. I'm not sure. And then they could conceivably come back, but there would probably be a lot fewer of them, in that case. And so his was a simulation. Mine is data from the shroud. So, which raises the interesting question: could neutron radiation affect the fluorescence intensity of linen? Now, when I was getting ready for this, I looked back at Schneider's paper, and what he found was that even though it was called the Z-score, it was fluorescence intensity. They're essentially the same variable. And the actual radiocarbon dates seem to be correlated with the fluorescence intensity in his paper, with the 3 points that I put on in the beginning. So, but originally when I looked at this, I said, boy, it looks like an apple and an orange comparison, that you're going to compare fluorescence intensity with neutron radiation effects. So I got some linen samples. I actually got them from Bob Rucker's daughter. They had gotten them from Europe, and they were, I believe, made in the way that they did linen back in Christ's time. And I had experiments done at UMass Lowell. They have a neutron reactor there. And I had 8 of the samples irradiated at different fluxes. And what I found is shown in this slide, which I'll put up and hopefully people can see it. This is taken from that paper as well. And this is a plot of the y-axis is the average fluorescence intensity of a sample, and the x-axis is the neutron fluence or flux that it was exposed to. And you can see that there's an increasing trend there. The last 4 points bounce around, and I think that may be due to the fact that those linen samples showed some evidence of burning. So that flux may have been high enough to cause a degradation in the linen. The first 5 points, one of them is a control, don't show such a variation there. But this then said, wow, neutron radiation is potentially an explanation for why these properties of the shroud, the fluorescence intensity properties of the shroud, actually exist. And so it wasn't an apple and orange comparison after all. And so that kind of is where almost where the paper in the International Journal ended. And then in the recommendations, let me say a couple of things. One is neutron radiation could explain the fluorescence intensity. If it doesn't, then the question is, what does explain that trend that I saw? And is there another phenomenon that people could look to that would explain it? Now, I think what's needed in order to answer the question is more research on the shroud. I would suspect that some of the people you've interviewed said the same thing. And
they all said the same thing.
Non-destructive research.
Exactly.
And so let me give you two examples. One would be the shroud was cleaned in 2002, and the areas that were burned had charred material underneath the shroud, and that was collected and put into vials, and they marked where it was taken from. And most of those burn areas are going to be closer to the center of the shroud than where the radiocarbon dating was done. Now, that burned material is absolutely useless in terms of its effect on the shroud today. All it is charred material from the shroud. So if you did something with it, you wouldn't have any effect on the shroud. And it should date to the future if it's radiocarbon dated, as Rucker simulation shows, if he's right about neutron radiation. So that would be one, very easy experiment to do that wouldn't hurt the shroud.
I think that's one of the most fascinating things. And I did interview Robert Rucker as well. And we discussed exactly that. So as you get towards the center of the shroud, towards where the heads are, the face and the back of the head, then you would potentially expect up there that the radiocarbon date would be positive because of all of the extra neutrons that would have been absorbed. And I think that'd be and if you could use the destructive testing on what's already been removed to validate that, that'd be a very good way to validate his theory on the neutron.
Exactly. I think he's tried to get them to do that without success. I think a number of people have tried to approach the people that own the rights to the shroud. They kind of have their head in a foxhole. I think that they were hurt by the 1988 radiocarbon dating, and there've been so much work done since then, and a lot of potentially interesting experiments. There was a paper that just came out by Giulio Fanti where he used wide-angle X-ray scattering, and they were using that to date a really tiny piece of the shroud, and he had actually developed his calibration from maybe 8 or 10 historic samples of linen. And the nice thing about that is that it's non-destructive. So he could actually take multiple readings on his little piece of linen. And that would be interesting to do as well as another method. And then the last thing I would like to see them do, I mean, there are a lot of things that they could do, is take, and I mentioned this earlier, take ultraviolet photos of the shroud, but do it with a uniform lighting. So now you can get pixel by pixel information about the fluorescence intensity and just see what's going on that way, as opposed to averaging over. It'd be, I guess it's maybe 1/16 of the shroud if there are 8 photos down each way and whatnot. So, so I think those are all, and there are a lot more non-destructive tests that could be done that could begin to answer some of these questions.
Well, and I think the point about being non-destructive is pretty critical, and that's one of the shames of the carbon dating, and then to put so much reliance, as somebody that doesn't believe in the shroud, to put so much reliance on that data that came out of that, and yet there were so many issues in terms of where they collected the samples and all of the other potential errors that could have corrupted the results. And then with Rucker's hypothesis in terms of the neutron absorption is that it's possible that those results are actually correct.
Yeah, I think
the neutron absorption. Yeah.
I mean, Rucker is basically saying this, that to me, the fact that they're dating that to medieval times, well, two things. One, the statistics were not done right in 1988, and it took a lawsuit, Freedom of Information lawsuit against the British Museum to get the raw data. And when that was made public, one of the things that was noticed was, I think it was Arizona, actually tested 8 samples, and they did not report 8 results, because if they did, then they could not have concluded that it was dating to medieval times. So they averaged sets of 2, and then they could come up with their conclusion. And what Rucker is saying is that the medieval results, or the way that they should have interpreted the statistics there, was that there's a trend in the data. We can't say it's a fixed year. And that's exactly what the correlation that Schneider had shows and Rucker's work shows. And unfortunately, the damage was done when they fudged the statistics and published it. And we're still living with that today. And it's a shame, but.
Yeah, it really is. Although I think finally, when I see all of the research and papers being written, it just seems like in the last year or two, there seems to be an acceleration of new thoughts coming out on it. And so there was, right after that radiocarbon dating, I mean, it just seemed like everything fell off a cliff, and then slowly started to come back. And now when I look at all the papers, like your papers and Rucker and a handful of others, there's just so much now going on, and all of it now clamoring, so to speak, to get access to the Shroud to do non-destructive testing, and to do it in a way that provides, something that can give us a valid date. So if we could do the ultraviolet testing non-destructively, if we could do that X-ray scattering non-destructively, and any of the other tests that are out there, I think we could really see then whether that radiocarbon date was right, and it could have been right, could have been the neutron absorption that messed it up, or that maybe something else was going on, and that the real date then is truly around the in Jesus era there.
Yeah, in the 1st century. I sometimes think maybe, although I when I look at what they pulled with the statistics in that 1988 paper, 89 paper, it could be a blessing in disguise, because a lot of people started looking at all kinds of research that they may not have looked at had the Shroud dated back to the 1st century. So that could be the blessing in disguise. But clearly that was a terrible thing to do, to cover that up that way. And
yeah.
And the damage that they did was enormous. So
yeah, it really was. And but if you think about Churchill, I think it was him that said, "The only statistics I believe are my own." And so that might actually be not so bad. But I do like your point that when you think about what Rucker's theory is in terms of the neutron absorption, and that those dates may actually be correct. That's mind-boggling. And then the second piece is that if you get to certain spots on the Shroud, it may actually date to the future, which would really be, really blow the skeptics out of the water. It'd be fascinating to see that.
One other test that I did that is in that paper, I had one piece of linen, modern linen, that was irradiated that would date to medieval times, and I had it tested for radioactive chlorine out at, I think it was Lawrence Livermore Labs. And the amount of chlorine that it tested for was about 2,000 times greater than what would occur in nature. So that charred material potentially could be tested for radioactive chlorine, although it's a gas, and conceivably it could have been evaporated or boiled off. But the other thing is radioactive calcium. And that test would be non-destructive. I mean, it would just destroy the charred material. So there are a lot of things, and that's only a handful. I'm sure that there are a dozen tests that could be done. Could be done.
Well, I liked your paper too about I think it was chlorine 36 versus the other chlorines, and then looking at that ratio. But I hadn't thought about the fact that it's a gas. Yeah. And then to your point, it may have boiled off. So if there was calcium in there, then the calcium would
calcium, you can create calcium 41, I think it is, from neutron radiation, and you can create chlorine 36, or I think it is, from neutron radiation. And their half-lives are like hundreds of thousands of years. So if they were created, they're going to be there today. They're not going to decay like radioactive carbon has a much smaller half-life. So that's another test. And as I say, that's only scratching the surface. And So I hope in my lifetime that they do the extra testing, but we'll see. We need to have pressure on them to come out of the foxhole.
Yeah, exactly. Well, I kind of think about it as the Jews were 40 years in the wilderness. And so 1988, the scientists will be 40 years in the wilderness before we get another chance at it.
Exactly. Exactly.
Yeah, maybe. Well, anything else you'd like to add?
No, that's it. And so it's been great. I've appreciated interacting with people like Mark Antonacci and Bob Rucker, and Giulio Fanti has been fabulous. I've interacted with him more recently. So it's a great group of people, and they're very dedicated. So that's been wonderful.
Yeah, and you're so right about that. I've interacted with quite a few now, and it is fascinating to talk to them and get them that the understanding that they have, and then the very specific question that they're trying to resolve, and it's been fascinating, and and to your point, it's such a shame that the radiocarbon dating was so poorly done, especially as it related to the statistics around it. And had they published that early on, then I think the results wouldn't have been so so damning.
Absolutely, yeah. They should have. Their proper conclusion was, we can't date the shroud because there's a trend present in the data. That's what the statistics show, and that's what they should have said. But they
and if they had done that, then I think the church would have allowed other testing on it.
Absolutely.
Maybe not destructive testing, but as science has evolved and the non-destructive testing has gotten more sophisticated, we could have been testing this over the last 30 years since 1988.
Absolutely.
And getting to the next and the next and the next level of detail on exactly what happened with that shroud.
Yeah. And they basically twisted Arizona's arms and said, don't report the 8 points, report average of 4 or 4 averages, and then that made their statistics work, and that was a crime.
Really. Well, Tom, thank you so much.
All right. Really, well, it's been a pleasure. Thank you for inviting me. I appreciate it.
Absolutely. And so your papers, just to reiterate, there's some of them that you referenced today. They're on shroud.com.
Right.
And then the one paper that you also mentioned is at researchgate.net. And what we'll do as well is I will reference those with a link on guypowell.com and actually, hopefully get the exact link to a couple of those papers and then go from there.
All right.
Otherwise, and so again, thank you so much. Really appreciate it. And otherwise, stay tuned for many others videos in this series of the backstory on the Shroud of Turin. Please visit guypowell.com and sign up for more episodes. And if you like this one, please rate it with 5 stars. Thank you so much, Tom.
Right. Thank you, Guy. Thanks for inviting me. Have a great day.